Hi guys, we're here on the second last drawing that we're going to look at for this little project, and this one shows our elevations, or two of our elevations and a section running through the middle. So the elevations are basically giving us all the information that relates to the heights of the building. However, I did say on the last video that I was going to talk about the difference between the barge board and the fascia board. And a fascia board would run along a horizontal section of roof like this. Doesn't matter where it is, it's horizontal. The barge board is exactly the same piece of material, whether it's steel or timber, and it's going to run up and down this inclined area of the roof as shown. We call that triangle in there the gable. Okay, and this inclined section of roof on the end we called the hip. Okay, so looking at this, we've got a bit of a blur up there, but that is the same number there, a reduced level of 31.2 for the ridge, the highest point. And this is the part I was talking about where if you walked up the hill here, walked up a hill incline, you came in line with that little ridge, you can see that it clearly is lower than the main ridge. Okay, as far as windows are concerned, we did note on the plan that there are no dimensions that depict exactly where the windows should go, and there's nothing on the elevation to tell us the height. So that opens up a potential for arguments with the client because your taste is not the same as theirs and you put the windows in a slightly different position. So it's an area that you really need to open up a bit of dialogue and have a chat to the client about if you don't already have an architect involved on the project. Okay, so what do we got here? We're looking here, colour-bond metal roof as selected. That's the same as on the plan, on the roof plan. Same information about the fascia, gutter, downpipe and so on. Timber framed external walls, selected boarding, aluminium framed windows. Now there is a line that runs out of that note up to the windows, both those little dots on the windows there. No point of the proposed residence is higher than 10 metres above natural ground level. That's the maximum building height. We did make a note of that in class. Timber stairs, 1,000 high selected balustrade. So the balustrade is built in here at the end of the little landing, and you would have one running along the side here to stop people falling off the deck. You actually only need those if the fall is over 1 metre, but it's a good idea to have one anyway. Timber veranda post, roof beam over. So this is the post, and you'll have a beam that runs between the edge of the post and the garage. That's the side of the garage there. That's the post I mentioned earlier that you could wind up having a bit of a debate about the cost because it hasn't been specified. What we've got here is brickwork below floor level. That's going to be our floor level in there. Normally we would have FFL, finished floor level, and we would have another note somewhere for FCL, finished ceiling level. We've been given a height here of 2440. That equates to 8 feet in the old language. Sorry, I'm sort of jumping around a little bit, but coming down through here, face brick foundation walls that's selected. So there should be subfloor walls rather than foundation walls. We've been given reduced levels, or basically heights of the ground, on the corners of the building. So you can see the 2575 in here, 2450 down there. So it's 1250 lower. Then we've got the same thing at the other side and at the front of the house there. This dark line here represents the finished ground line where the natural surface of the ground has been cut. In the section goes through the garage, so we miss looking at the stairs in here. So this is a vertical section. We've cut vertically and we're looking horizontally. Timber roof trusses to manufacturer specifications. And the beauty of the timber roof trusses is that they are fabricated off-site whilst you are doing other works, and they're also engineer designed and certified, so you don't have to worry about them basically being inadequate. The problem with timber roof trusses is they do consume a lot of space there, so you can't store materials up on the roof so easily, and they can't be changed without the engineer being involved again. The roof pitch there is shown at 20 degrees. That's 20 degrees above the horizontal, as mentioned earlier. 450 wide eaves. That's the flat area there. They could be raked, it could be actually inclined to follow the roof pitch, but generally they're boxed eaves. We've got our RLs there for showing the different floor heights. Down here we've got strip footing. So these rectangles full of little dots are indicating reinforced concrete. We've got a reinforced concrete floor slab to the engineer's detail. And with both those, the floor slab and the strip footings, we don't get involved in any of the design of that because we don't have the expertise in the eyes of the law. So we leave that to the engineers who've studied and done a lot of calculations for the last 4 years. Or over 4 years anyway. Okay, so we've got pad footings in here at various locations. Pad footings are just a blob of concrete in the ground, and sometimes they're actually called blob footings. We're going to build small brick piers on top of those to create a uniform floor height. So we're going to have a timber bearer and joist construction. And we will need to allow a bit of subfloor ventilation to keep make it less favourable for termites. Okay, I think what we'll do now is go and have a look at the other elevations that show similar information, but we're looking at the rest of the house.